She's in love with herself. Grey Wolf Studios.
So guys, it's Grey Wolf, and I'm here to do a video about power supplies, turning an ATX power supply into a power source for your DC lipo chargers. This is going to be the quickie version. This is for you folks that already know about resistors and electronics and voltages and, PCs, things like that. This will give you a quick walkthrough on, the basic things that you need to do to make this into a usable power source to charge your lipos. I also have an epic video that's in the works. It's going to be a multi-part video. I don't know how many parts yet, but it's going to be a multi-part video. It's going to be like a handhold session for the folks that know nothing about computers, know nothing about electronics, know nothing about resistors, LEDs, anything like that. It basically takes you step by step through the whole process. I go through the whole thing, one painstaking piece at a time, and you can kind of follow along with it and do yours while I'm doing mine. But not everybody needs that, so here you guys go. This is mine. I've got the lid off of it at the moment. As you can see, my original power supply had a big 120 millimeter fan inside of it, and what you have to do is you end up having to take it and mount it on the outside because you got to make room for some additional wiring inside the box that wouldn't normally fit. So there's basically two ways you can do this. You can do it the hard way, which is more aesthetically pleasing, which is the way I did it, or you can do it the easy way. The hard way is to buy actual banana connectors and wire them up, mount them on the case, wire them up on the inside, and you can just plug your DC chargers into, directly into the banana clips, or the banana plugs rather. The other way you can do it is you can actually take these wires. Well, before I go on to the other way, so as you can see right here, if you don't know already, the yellow wires are 12 volt wires, the red is 5 volts, orange is 3.3 volts, and black of course is ground. So as you can see, I've actually got two 12 volt leads wired up here on the top, and let me see if I can find one. Okay, now you can see in here there's actually a yellow and black wire. There's actually two of these. The yellow and black wires, or sometimes they're brown, they can be miscellaneous colors. I think most of the modern PCs, or PSUs rather, made in the last few years are all yellow and black. Anyway, the yellow and black is your 4-pin motherboard connector, which is actually a separate second 12 volt rail in the power system. So what I do to divide up the load more evenly between all the wires is I actually run both the 12 volt rails in parallel. That way, the load gets split up onto both of the rails. I basically put one black and yellow wire in each one of these yellow connectors. Each one of them has one wire from each one, so it's using both rails at the same time. The only real benefit to that is, like I said, you can use more wires, which means you can do more amp draw without the wires getting hot. That's really the only big thing. I also, if you noticed, I also actually have indicators on the outside of the case using zip ties. You see how there's two yellow zip ties in the middle of the top two? That indicates the 12 volt leads. I have one red zip tie here, which means this is the 5 volt, and the orange zip tie here means that this is a 3.3. Now, I mounted an LED light, a 5mm LED light on mine, so I can more easily. Originally did it so I could more easily tell when it was turned on, because originally I didn't have an LED lit up fan on my case. Originally this fan had just a standard fan, didn't have any LEDs in it, so now it lights up like a Christmas tree when I turn it on, but originally it didn't, so I put an LED in it originally. And for the switch, I just used the switch that was already built into this power supply. Now you can buy any kind of single throw, single pole, or I forget. Anyway, you can use any standard 3-pole switch or 2-pole switch, whatever you have. Just a simple on-off switch of any kind, rocker switch, whatever works. If you're gonna wire up an LED, there's really only a couple things you got to know. The LED, the LED basically has. If you've never wired up LEDs before, when you see an LED, it's the green bulb with, or whatever color LED you have. It's the bulb with basically two metal prongs sticking off of it, and one prong is just a little bit longer than the other one. The shorter prong is your negative, the longer one is your positive. Now, you have to wire or solder in a 220 ohm half watt resistor into either the positive or the negative side of the LED. It doesn't matter which, but you got to put it in there on one side or the other, otherwise you'll burn out the LED. The LED mount itself is pretty basic. It's just a lock washer and a nut. Just slide it in, drill a little hole, slide it in, put the washer and nut on it, you're done. The first thing that you got to know is, okay, the green and black wires, I think I covered this already in another segment. The green and black wires are, you have to connect these two wires together in order for the power supply to think that it's plugged into the motherboard. If these two wires are not connected together, the thing won't turn on. So we're going to use a switch to connect them together, though, so we can turn it off and turn it on via a switch instead of having to plug it in and unplug it to turn it off and on. So the first thing I noticed when I went to connect these two was I noticed that the fan started to turn on. It kicked on and spun for just a second, just like that, and then stopped. Whenever you see that, that means that means you got to find. Okay, that means there's one more step that you have to do, basically. I was going to say it means there's a problem, but it's really not a problem. It's just something you have to address. And so I'm going to use this as a demonstration piece here, and I'll see how good I can zoom in on it here. So if you notice, this is the original wiring harness, the 20 or 24, it could be a 20 or 24 pin connector. And if you notice here in this one corner, you have a brown and a orange wire both going into the same pinhole. Can you guys see that? You have a brown and an orange wire going into the same pinhole right here. That means, and you'll notice that the brown wire is a thinner diameter than the thicker orange wire. That means this brown wire right here is what's called it's a sensing wire. And what it's designed to do is it's designed to sense that the motherboard is getting the right voltages from this 3.3 volt lead, and actually all the 3.3 volt leads. So what you have to do is you have to locate this brown sensing wire inside the power supply, which I've already done. It's right here. And all you got to do is solder it together with an orange wire, because that's the color. That's the color of the wire that it was hooked up to originally. Once you solder this to an orange wire, and then shrink some heat shrink around it, then again it's just like hooking the green wire to the black wire. We're fooling the power supply into thinking that these are still connected and it's getting the proper voltages. So once you get that done, you can tuck this away with all these other unused wires inside the case. Now, when you first start dealing with this, basically you're going to have all the wires, coming out of this hole in the back of the case. So what you want to do is you just want to cut off all the connectors. You just cut them off. I usually leave myself about 8 inches of wire hanging out the back to work with, and cut them all one length. Other than that, you are going to find 4 or 5 other colors of wire. Excuse me. You are going to find 4 or 5 other colors of wire inside of your power supply. If it's not yellow, orange, red, black, or green, you don't need it. I just put a piece of heat shrink tubing around everything else and set it off to just tuck it away to the side there, anywhere. Now, yes, I do have one red wire in here, but it was just because I couldn't fit it into this red volt connector, or this 5 volt red connector, so I just set it off to the side because it wouldn't fit in the ring connector. I had as many wires as I could cram in there already. Also, you need to wire into place a 10 ohm, 10 watt ceramic sandblock resistor. 5 volt lead positive on one side and a negative on the other side. What this does is creates a load on the 5 volt side of the power supply. A lot of power supplies require a 5 volt load to either A, operate the way they're supposed to, or to either operate at all, or B, to operate properly. Properly being when you put a load on the 12 volt side, the volts don't sag nearly as bad under load if you have a load existing on the 5 volt side. Now, that's not true of all power supplies. There are a handful of power supplies, from what I understand, that actually do not require a 5 volt load on them. Well, I don't know how to distinguish one from the other, so I suggest just putting a resistor on the 5 volt side, period. I did notice with this particular one that it actually required a load on the 5 volt side to even turn on. Now, I have another one of these that I did to power the server case fans for my my spray booth. That one, when I wired that one up, it actually worked without the sandblock resistor, but I did some testing with it, and I did notice that with that one, the voltage did not sag on the 12 volt side nearly as bad when I had the resistor in place. Now with that one, I'm just running 3.3 and 8.2 amp fans on it anyway, so it's not a huge deal. It wasn't dropping out drastically. I could have gone without putting it in there, and it's still basically what was happening was, with no load, the 12 volt side I think was registering something like 12.3 volts, When I turned all 3 fans on, no resistor on the 5-volt side, it would drop down to, I want to say 11.5 volts. You know, not terrible for what I'm using it for. You know, certainly won't hurt anything, won't hurt the fans or whatever. Yeah, they might not be spinning, you know, max RPMs or whatever, but it won't hurt them. However, once I put the sound block on the 5-volt side, the load only dropped from like 12.3 to 12. I want to say it was either 12 even or 11.9. I can't remember, but it was basically like half as much. So I recommend just go ahead and solder up the sand block resistor anyway. The only other thing that I think I haven't addressed yet is what I consider the easier way, the faster way. It's not quite as pretty, but it's functional way. Is instead of you know, harnessing all of these wires together and, you know, crimping them on ring connectors and doing all this fancy stuff, you know, with having to mount the bullet connectors and everything. The only reason I chose to do that on this case is because this case had this grid on the back, and I thought, oh, you know, how convenient, that'll be easy for mounting all these bullet connectors. Well, turns out it wasn't as easy as it looked, because they ended up short-circuiting or you know, shorting themselves out, because they were actually making contact with each other via the metal case. And I ended up having to take liquid tape and basically paint the front of this thing, drill holes in the liquid tape, push these through the liquid tape, screw them down, and then had to cut out around all the rings and then remove all the excess liquid tape to insulate them. It was a pain in the ass. You'd have to do something similar if you drilled holes in your case. You'd have to find some way to insulate it from actually touching the case. That's why I say the easier way, the less complicated way, is to leave all the wires sticking out of the back here. Just cut them off, leave about 6-8 inches of room. Just cut them off and then solder on bullet connectors to the back and just leave them all hang out the back. Typically, the 5-volt lead and the 3.3 volt lead I have on the front of this, I wired those up thinking that I might find a use for them somewhere down the line, but I haven't found a use for them yet, really. I think I've used the 5-volt side, I think, twice to test electronics. Couple of like fans. I mean, just very minor stuff. Didn't really need it. It was kind of handy, but didn't really need it. Anyway, you can wire up whatever voltages you want. I found absolutely no use for the 3.3 volt side so far. I've used the 5-volt side a couple of times. Whatever. So anyway, you can, like I said, you can do it and just leave the wires and the bullet connectors hanging out the back. Heat shrink them real good so they don't touch together, obviously. And you can run it like that. Then all you have to do is mount the switch if you need one. You know, solder these 2 wires together if you don't. Mount your sandbar resistor, mount your LED if you choose to use an LED, and mount the fan on the top of the case or the outside of the case. That's about it. Simple as that. There's really not much to it. So at any rate, that's pretty much it in a nutshell. My other video that I have is a epic walkthrough, literally step by step, like hold your hand walkthrough of how to do it. That was a huge undertaking, and I basically did it for people that are not, you know, if you're not electronically inclined, you don't know about, you know, you don't have any knowledge whatsoever about resistors or LEDs or switches or voltages, or basically, if all you know how to solder, if all you know how to do is solder, and you don't know anything else about electronics, you can follow that walkthrough. But I made this version for you guys that already know about a lot about that stuff, and basically just need to kind of know the basics of the main aspects to hit. So if you have any questions, feel free to contact me at greywolfstudios74 at gmail.com, or you can contact me. You can get a hold of me at rcnitrotalk.com. rcnitrotalk.com. Oh, you can't really see the M, can you? Anyway, and I could also be found on Facebook under Grey Wolf. Just look up Grey Wolf Studios 74. So if you know anybody that can benefit from these videos or would just like to see them, please feel free to pass them on, post them wherever. Please subscribe, and send me your questions and your comments. Email works best, but Facebook or RC Nitro Talk works too. And that's it for me. I'm out. Peace.